All right. Hello, everyone. My name is Simeon, and I will be introducing the first panel, New Frontiers in Space Technology. Moderating this panel will be Ishan, who is a staff member at SEDS-Canada. Our panelists today are Jason Micho, who is the CEO of Stardust Technologies, Julie Claveau, who is a program scientist for space astronomy and co-chair of the Women in STEM Advisory Committee at the Canadian Space Agency, and Dr. George Zhu, who is a professor and research chair at York University.
Perfect. Thank you for the introduction, Simeon. We are live, so thank you everyone for joining us and kind of being here today. I'm so excited to kick this panel off, New Frontiers in Space Technology. And kind of to set the stage and get right into it, as all of you know, the last few years have seen an accelerated growth in the space industry. Just the last year alone saw the launch of the James Webb Telescope, the deployment of the Perseverance rover, one of my favorites, a large number of Starship mishaps that are well documented on YouTube, among many other notable accomplishments. And an incredibly exciting part of this is that Canada has played an important role in many of these missions, and will continue to do so as we push the frontiers of space technology and research. So in this panel, essentially, I want to take a deep dive into what it's like to work on the cutting edge of the space field. And we have fantastic panelists here today to kind of share their experiences. And before we get into the questions and the meat of it, I'd like to go around the table, or the virtual table that we have here, to get some brief introductions about yourselves, a bit of background, and how you came to where you are today. So we'll just kind of go from my top to bottom. So Julie, if you want to kick us off.
Yes, absolutely. So as was said in the introduction, I'm a program scientist in space astronomy at the Canadian Space Agency. I'm an astrophysicist by profession, and I'm a UVic alumni. I'm also the Women in STEM co-chair of the Canadian Space Agency, so that's a really fun role to be in as well. So essentially a bit of my work path. I did in my undergrad. While I was an undergrad, I was a violin teacher, and then I became a naval warfare officer in the Navy. I continued that a little bit after my studies, and then I retired from the Navy, and I joined the public service as in administration. So lots of different administrative positions, and I really like that when you start a career, starting at the bottom, because you really get a feel and see the value of all the support that you get. Because, if you go right away in a higher level position, then you kind of lack that depth of understanding and respect for all the, the hard work that's been done for you to succeed or for your team to succeed. So that was a very valuable experience for me. And then I became a mission planner at the Canadian Space Agency after that. And that was for RADARSAT-2. So I did mission planning for RADARSAT-2. And then I was put on the RADARSAT-1 open data team as the project manager. So there was actually an announcement yesterday that a whole bunch of RADARSAT-1 data was open. So that was my team. And then now I'm actually working in space astronomy on JWST and James Webb Space Telescope, and AstroSat, amongst other things.
Amazing. We'll go clockwise. So Jason, if you want to go next.
Bonjour, Wache. Hello. My name is Jason Micho. I'm the CEO of Stardust Technology. Wonderful, small little Canadian team that's been making a lot of noise lately. And I would like to say that I'm kind of a mosquito in Canada when it comes to the space agency, because I love to disrupt a little bit and make it a lot more accessible to youth across Canada. And STEM is a core focus in our enterprise to promote space for the youth. And I really got in this out of passion of helping people and creating opportunities for everyone, and showing that Canada can do even more with the right participation and education with the youth. And we've been involved with multiple collaborations across the world, including Brazil, Australia, Luxembourg, and Japan. And it's just been a wonderful journey, and space is just an amazing passion, and I wouldn't be here without my amazing team.
Awesome. Dr. Zhu.
Okay, thank you for your introduction. So I'm a professor and the York Research Chair in Space Technology at the Department of Mechanical Engineering at the York University. My research interest is quite a diverse area that covers the dynamics and control of a spacecraft, especially tethered spacecraft. I will talk later. Space tethers and autonomous space robotics, space debris removal, and additive manufacturing in space. I'm also the academic director of Research Commons at the Vice President of Research and Innovation. So, in that role, I push forward the research intensification effort across the university. So, my way to the space sector is nothing special. Before I joined York University as a professor in industry design, I worked in an industry, in Canadian industry, to design special heavy Navy equipment, such as towed solar array system, a special system to assist helicopters landing on ship for Canadian navies. And at that time, when I joined York University, there was no mechanical engineering, but I have to choose a department as my home department. So I choose the Department of Earth and Space Science and Engineering. And immediately I was fascinated by my colleagues' work. York has a very strong research in space science. In that time, in 2007, I think my colleagues designed a payload like the laser instrument on the I think the Mars Phoenix mission, and they discovered the snow falling on Mars in the first time. That was so fascinating. So I quickly emerged into that area with my special cable handling system. So I just turned the cable into space as a space tether, such as the space elevator, electrodynamic tether, and this kind of thing. So in 2020, we launched a CubeSat to test those tether technologies. Thanks for Space Agency, Canadian Space Agency support our mission. So currently I'm working on this subject like the space elevator, electro solar wind cell. There's also like space tethers, space robotics, and the building and the launch CubeSat at the York University. Thank you.
Awesome. So yeah, we have a very varied background and kind of different fields within space covered here. So I'm sure we'll hear a lot of your experiences and about these cutting edges of the space field. So with today's panel, I've kind of split it up into two blocks. And the first of which is focused more on the developments in 2021, kind of covering the exceptional growth and kind of new stuff that we've seen the last year. So kind of in this regard, to set the stage, if I say so, 2021 was an incredibly tough year for all of us, with COVID and kind of transitioning to this online environment. Here we are on an online conference. But it was also a tremendous year for space enthusiasts and the developments we saw. So I'd like to get or focus our attention first on these frontiers and specifically get a deeper look at your own experiences from the projects that have stood out to you the most to, perhaps looking at what's to come in the future. So in this regard, again, just going around the table, I'd like to get maybe what have been some of your standout moments or achievements of 2021. And specifically, I'd like to hear about your personal experiences or personal role in some of these projects. And we'll stick with the same order because it's working so well so far.
So I guess me first? Yeah.
You first.
Sorry. Okay, so my favorite moment last year was what lies, the launch of the James Webb Space Telescope. That's what I'm working on right now, and that was really a momentous and long-awaited moment for me, and I'm sure all of us. It's super incredible what humanity can do when we put our differences aside and work together on a common goal. And I'm super excited to see the discoveries that we're all going to uncover using this telescope. For me specifically, it's related to the period of reionization, where the first light after the Big Bang occurred, and just knowing and understanding and seeing how the first stars and the first galaxies form. So I'm really excited for that. So that was like my favorite moment of 2021. So my role in the mission is essentially program scientist. So I essentially work, I mean, there's lots of roles, but program scientist essentially, I work with international partners like NASA and ESA to deliver on the mission objective. So Canada had said that they were going to deliver a particular instrument, which is the FGS nearest, and we did deliver it. It was installed. So it's a fine guidance sensor to allow James Webb to know where it's located in space and really make sure that it's it's locked onto its target and it stays locked on its target when it's observing. And then there's the nearest, which is a near infrared near infrared instrument and slitless spectrograph. I always miss a word in there, but so that one is going to be to study exoplanets and the different transit spectroscopy. So when a planet goes in front of another star, and it goes between that star and our star, that star and us, the light goes through the atmosphere and we'll be able to see what the atmosphere is made of. So that is my role in the mission, essentially making sure that Canada delivers on its contribution. And that involves contracts, contributions, contracts with industry. In this case, it was ComDev and now Honeywell. And there's also contributions and other contracts with universities to develop the software that goes with, the FGS NIRS, because there's the instrument and then there's the software. And then making sure that all of our research scientists get their 5% observation time that was promised to us once we contributed those two instruments. So I also manage all the grants and make sure that the funding goes to our research scientists once the observations come in. So that's a very small part, like James Webb. I also work on AstroSat and other memorandums of understanding with other government departments. And I'm not sure if I've surpassed, I've gone over my time. I'm not sure, but anyways, there's a whole bunch of other things that I found really, really interesting this year. But that was really my top.
I'm sure we'll have a lot of questions at the end. By the way, for the audience, feel free to throw your questions out now. We're monitoring the chat and we'll write them down. So there will be time at the end, hopefully, to ask some of those. But yeah, no, that's incredible, Julie. I'll pass it to Jason next.
Hello again. So these are incredible things that happen, and definitely the James Webb is very inspiring. I would say it's gonna allow us to be able to see so far more, in our the history of the universe, and in that regards, it's very amazing. Myself personally, I was really amazed by the tenacity of the industry and the youth that are involved in so many projects across Canada that kept pushing forward despite these lockdowns and these headaches of trying to get stuff going, and they didn't quit. They just keep going. And one honorable great mention is the wonderful team at Space Concordia, everything they've been through to get their rocket going. That's just been amazing. And another thing that I would love to highlight is the collaborations that we did with the Anishinaabe Ashki Nation, with Grand Chief Derek Fox, with STEM outreach for the Indigenous youth in Northern Ontario was such a very great thing, because outside of the big cities, sometimes it might be a bit tricky to get youth involved in space, because there's still a lot of people that think unfortunately that we never landed on the moon or the earth is flat. So there's a lot of work to do on the education side, and it holds a very dear place in my heart, and I think it's really something that we've advanced in 2021, but we got to push even further. And I think the industry has just been going so crazy good right now, in the sense that a lot of people are starting new startups and just pushing. And to me, at my core, that's what I really love seeing. Canada not just focusing just on niche, but really pushing towards new boundaries, and showing that we can do as much as they can do in the US and Canada. And that's one of my highlights, and all the collaborations we did at Stardust, including the robotic arms with haptics that will be going to the moon in 2024 with haptics feedback to record the sensation of touching the moon, so that we can inspire future generations of youth to actually touch the moon in with virtual reality, so that they can one day want to go up there and touch the moon. That again, it's been an incredible year, and the space family is just expanding, and it warms my heart, and really happy of the work that the CSA has been doing and Canada has been doing in general. So.
Yeah, no, I couldn't agree more. And I think one of the places you see that most of that change that has been, we've had a transition with this online and kind of adapting to these challenges has been through in universities and through our education systems. So I'll pass it to Dr. Zhu next to kind of tell us what his last year's looked like. And
yeah, it's so exciting to hear Julia and Jason talking about the great things in space. It's more like in the big area, a large stage, like Julia represents CSA, the James Webb Station. It's kind of international news. For university, we will focus on more education and fundamental research. So actually 2021 for me, it's a very good year for me. So I received 2 large research grants to support my research. It's almost $10 million. So the first one is a $9 million instrument infrastructure funds from the Canadian Innovation Fund, which I worked so hard in the past 5 years. We pushed for made in space. So the project will allow us to build the first research hub in Canada to do the made in space. That will involve this 3D printing, using the laser, doing the metal, non-metal stuff, so we can build, fabricate satellite payload in space instead of we launch from Earth. That wastes a lot of energy in the space. And also we will do the, we call the 3D bioprinting. That is kind of fascinating. We want to printing like a skin, a blood vessel, bone implant. And so in the future, we can treat our astronauts in the mission. For example, if we, in the future, if we want to go to the Mars, the one-way time will probably more than 1 year. And if some accident happened and to our astronaut, there's no way you can send those astronauts back to Earth to get treatment, right? So that's the exciting things we want to do. We want to make this piece like the treatment, medical treatment in the spot that can treat those astronauts. So the second things, we got a $1.6 million from Canadian NSERC. That is also called Smart Autonomous Robotics Technology for Space Exploration. We are, in the next 6 years, we are training over 100 students in that field. We're training students in the artificial intelligence, autonomous robotics, computer vision, and space exploration. So all the students you are here, welcome to apply for that program. We need a lot of talented people like you to join us. And also exciting things, our research in space elevator, we call the floating space elevator, get attention from the people in California. So speeding people think, hey, it might be feasible to build a space elevator now. So this is another exciting thing for us. So I stop here. But I can go on and go on. There's so many exciting things about the space.
Yeah, so one of my questions that naturally comes up when you mention, things like the James Webb Telescope and space elevators and all this incredible work is that, there's no solution manuals to these kind of projects. There's no cheat sheet that you can look at it, how do we do this? Or if it's been, sometimes in university or when we're studying for exams, like you can go to the back of the textbook, you see what the answer is, and it helps you kind of work your way there when you're working on this problem. But for you all, I guess what are some of the challenges that come up when you're kind of working on this cutting edge, and how do you go about navigating them? I just see this as an open discussion for anyone.
The audio went kind of funny. Is it just me? Can you get? Okay, good. Okay,
Same
can you guys hear
idea.
me?
Yeah,
Okay,
no,
good. I wasn't sure if it was me or if it was okay. Good.
Oh.
Now I can hear you well. So, did you want to do the same thing again, or are you calling somebody first?
No, I'll. Was my question clear?
yeah.
Okay, yeah. Then in this case, I was just going to open it up for whoever wants to chime in and then answer.
Dr. Zhu, you can go first.
Yeah, yeah, I can go first this round. So I think for the space exploration and the technology development, everything is new. Especially in university, we somehow we cannot compete with our industry partner. We have to do something a little bit future. Sometimes they call it the futurism and the future research. So my advice is that we always treat this with, say, some of the general ideas coming into the imagination is kind of half science fiction, and half science. So you have to combine the both and to find a new solution. There's no cheat sheet. You have to be bold and be full of imagination to find a new idea and to find a new solution. So that's the way we are doing in university.
Did you want to add something, Jason?
I just think that really you just gotta be you gotta be bold, and you just gotta go for it, and you gotta come up with some very creative ideas, and that's what passionates me so much about this industry. It's really about just thinking outside the box, and there's no cheat sheet. Most of it is waters that haven't been all navigated, unless you're doing something that's a bit redundant. You're going to go in uncharted water, because space is the new frontier for humanity, and that's why I really enjoy it, because everyone wants to collaborate, in the sense that there's a sense that we're not as much competition, but we want to like figure it out as a big family. So.
Yeah, actually, that's one of the things that I was going to say, Jason, that you need to lean on your colleagues, your network, and everybody's diversity. Like, everybody has different types of knowledge and experiences. So we need to draw from each other's diversity. You need to lean on each other, ask for help, discuss perspective, ask questions, find possible solutions, try them, fail, try again, fail again, and then just keep going until you succeed. That's usually the way that I approach challenging things that have never been done before.
And I mean, failure, like, you're gonna fail so many times before you succeed, and failure is just part of the equation at the end of the day, and failure is just gonna make you better. So you can't just quit. You just gotta keep going and push forward, and you'll get there.
Yeah, and I also want to add, I like the word Jason used, like a family. We lean on each other, especially when you come up with some bold new idea. People are laughing at it. What? Is that feasible, or you are just dreaming? So right, so we need to find the people with the same interest and work as a kind of consortium to push the boundary. That's the part. Yeah.
Yeah, and I mean, like, coming from a small village of less than 900 people in Duberville, between and middle of nowhere, in between Walwa and White River, it is very hard to explain to people that, hey, I'm working in space, in the space industry, or I'm interested in space. No one really wants to talk about that, so it's I think it's really about finding your family in this industry, and leaning on each other, like you said. It's just the best way to do it. And don't be afraid of asking questions. Everyone's there to help each other, and if someone says that it's impossible, more than likely it's possible. It's just they don't want to do it. So.
Yeah, I mean, that kind of brings me exactly to my next question that I wanted to ask, which is more about, well, the space industry is kind of one of the most collaborative, I would say. It involves international collaboration, and we can say Canada has played an integral role in many of the initiatives that we see today, even though it isn't always obvious. So I'd like to kind of hear about kind of some of the standout collaborations that you've been a part of that have maybe opened your eyes to new technologies or stuff that you haven't seen done before. Maybe opened kind of a new perspective of doing things. And we'll go back in order from Julie and across to keep things a little bit more ordered.
Sure. So, I mean, every project that I've been on at the CSA has had an international partner of some kind. I mean, that kind of goes with the job. I mean, James Webb, NASA-led, CSA and ESA partners. AstroSat actually is India-led, led by India, and CSA has contributed an instrument to it and got observation time in return. Even like RadarSat, the RadarSat missions, I mean, they're purely Canadian, but I mean, that's not true. Sorry, it's not exactly true, because for RadarSat 1, for example, like, well, for all of them, their orbit, wherever they're at in their orbit, they need to downlink somewhere on Earth, you know, when the hardware is full, and then they need to downlink the images so that it can take more images. So there's reception stations all across the world, and we actually had to work with international partners at that time, essentially for that, so that whenever RadarSat 1 was in orbit, and even for RadarSat 2 and RCM, wherever it's at, it's going to, let's say it's over China, that it's going to downlink in China, right? So we have international partnerships with the RadarSat missions as well, even though they're mostly Canadian missions. The launching capability, we didn't have the launching capability, so we had to, you know, lean on international partners. The International Space Station, again, like, it's an international collaboration. Everything we do at the CSA, Lunar Gateway, OSIRIS-REx, like everything's international. So yeah, I mean, I think there was a second part. So what's my experience? I mean, I guess my experience is that I found that in working together, it really allows us to draw from each other's skills, knowledge, and expertise, because every country and every person has their own skill set, their own capabilities. And we can only achieve greatness if we work together and on a common goal. And then we all draw benefits from it and from the results together. So yeah, that's what I have to say.
Perfect. Jason, are you?
I mean, it could have been better said, really. And I mean, collaboration, as I highlighted it a little bit earlier in the conversation. We thrive on collaboration because we believe that space is for everyone and it doesn't have a border because it's for humanity. And reasons why we partnered with the University of Technology Sydney in Australia, Explore Space, and iSpace in Europe and Japan for some of our project. It's just because there's more strength in numbers, and you can be a lot louder and push the project to fruition. And I mean, at the end of the day, the way I see it is it's a big potluck. When we do a big potluck, everyone brings something to the table, something different and unique, and that's what makes it so important to get different perspectives. And every country has different perspectives about space, and we shouldn't just necessarily focus on our little area and be closed-minded. New space is all about collaboration, and that's how the future of humanity is going to get to space, not just relying on one person.
Yeah. Dr. Zhu, do you have any specific examples of?
Yeah, I just couldn't agree more, because the space exploration, it's interdisciplinary. Excuse me, I use some more academic word. Because if you do the space, that involves everything almost, and you cannot have one expert cover everything. So collaboration it's basic, and for us, if we want to do this, like the space elevators, and we have to work internationally, because that involves so many areas like material, systems, launch, and all the engineering issues. So we form, actually, in my personal experience. So we formed a kind of space data research consortiums internationally, which draw all the talent from all over the world, and we continue to push this idea because I know Julius here, and so a lot of space agencies think space elevator is a high risky project. Maybe it's not the current technology can do it, but we still that's the international consortium actually will push that frontier quite well.
Mm-hmm. Yeah, no, it's awesome. I'm seeing the time here, so I'll take us on a bit of a jump into our second block, which is I guess the theme from it kind of stems from last year's conference, which was the idea that technologies developed first for space often have some of the biggest impacts here on Earth, and even more so, investors and government agencies really look for these applications before committing to any planned space project or research. So kind of on this line, I'd like to start off and kind of discuss how have some of the technologies or these cutting edge space research that you've been a part of, how do you see it affecting life on Earth? And we'll start again with Julie, or
yeah, sure. How do I see it affecting Earth? Oh my God, there's so many. Where do I start? Okay, so let's do this quickly. So Canadarm3, AI robotics, right? So remote medicine, like directly applicable to Earth. So if a robotic arm can do things by itself, with little human intervention, then it can do the same in, let's say, for example, in medicine. So a whole bunch of really interesting things that could happen with AI robotics. A RadarSat 1, a RadarSat 2, RCM, so Earth observation in general, is really booming right now because it has so many different applications in terms of disaster management. There's a big tsunami, you can use EO data. Monitoring the ice melting, another big way that it can impact Earth. Agriculture, the harvests and making sure that we have the most abundant harvest, we can use EO data for that as well. What else? JWST. So the hardware that's being developed by Canada for the mission is going to be useful in other positioning and navigation systems as well. So there's just so many to pick from. That's the main one that I can think of right now. I know like Wi-Fi has something to do with instruments that were made specifically for astronomy, cell phones, laptops, understanding basic physics. What else? And the space station. There's so much stuff going on in the space station in terms of research that helps us improve healthcare. I
guess to narrow down.
Sorry. So lots of stuff.
Diapers.
Well, to narrow down, and I'm kind of curious to get your take on it. With the James Webb Telescope, this is such a big milestone for us. How do you see the pictures that we get back from it impacting how people perceive space or kind of...
You're asking Julie?
You're muted, Julie.
Okay, well, I wasn't muted before, was I? No, okay. Just said all of that muted. Nobody told me. Sorry. Are you asking me or somebody else?
Yeah, I just wanted to...
Okay, so, I think we need to remember that every technology that has been created up until now is based off of fundamental physics, right? Core mechanics and whatnot. So if you can't understand, gravity, you can't, build a computer. Like there's a sequential flow from fundamental research and science, and then it goes into engineering, and then it goes into research and an industry, and then international partnerships to get more. So James Webb, we're going to be able to see the beginning of the universe. So we've never even seen it. It's purely theoretical right now. We're actually going to be able to see it. We're going to learn about, how black holes, how stars form, about, exoplanets and the compositions of their atmospheres. And there's just so many things that we're going to discover using James Webb. It's hard to say exactly what we're going to discover specifically and how it's going to have a direct implication, but for sure it's going to have an impact on fundamental physics, which eventually will have an impact on the technologies that we're able to develop because we'll understand our universe better.
Yeah, for sure. And for Jason, simply me being able to touch the moon and know what it feels like is enough of an impact for me, but I'll pass it to you.
I mean, you definitely want to inspire the youth that are in 20 years from now or 30 years from now will be leading, because they're going to be the ones that are going to have a political impact on the industry. And at the end of the day, you want space to keep going. You don't want it to go dormant like with the after Apollo, unfortunately. So you got to keep inspiring them, and it starts with education. And that's going to be a huge thing for offer. But anyways, getting back to another thing that we do that we believe will impact a lot of lives as well on Earth is the Eden project, which we've did microgravity flights earlier in 2021 with the collaboration of the Canadian Space Agency and the National Research Council of Canada. We've tested successfully untethered VR in microgravity with the Eden project to test the effects of helping people with the Eden project. Can you still hear me? Because I'm not
Yeah.
okay.
Yeah,
I'm not hearing the background noise
yeah, the
anymore. That was
background was
weird.
gone.
Okay, that was so weird. Sorry about that. So ultimately, we believe that if we can help people that are in really closed spaces in space, dealing with mental health, that can't really go for walks and stuff like that, it can also help lots of people that have been suffering with mental health on Earth, especially in remote communities that are not as much exposed to the services and stuff. I mean, sometimes when you're not able to go anywhere or do anything, and there's a lockdown, you might feel like you're alone in this world. And if you're used to talking to a lot of people and going to see them, it just drains you. And I can talk from a personal level that mentally it's been very hard to cope with these lockdowns. And I think that any like forms of research in mental health will really benefit on Earth, as well as any type of technology that we can relate. That such as satellites will really benefit for climate change studies and farming and patterns. Hopefully, make it a bit more predictable for weathers. That, but I can attest to that because we got minus 50 degrees Celsius not too long ago, but they said it wasn't going to be that. But so it's going to get even better. But no, everything that space is definitely doing is reinvested on Earth. I would say tenfolds of. I mean, there's just so many technology. We wouldn't even be talking right now if it wasn't for space. I don't think, anyways. We'd be probably behind a few years. So I'd say for those that don't believe in space, you guys start embracing it. But I guess I'm not preaching to the right people right now. I think everyone here loves space.
Yeah. I mean, Canadian weather is pretty hard to predict. So
Just for an example, I went sleeping in the forest for a deep, dead of winter camping, and it was supposed to be -6, and it was minus 25 with the wind. So
Dr. Zhu, do you want to round us out?
Yeah, I just add a little. I think the Julie and Jason add a lot. So the space actually just affect everything here. Even when currently we are using the internet, like some signal transmitted through the satellite, right? And for us, this all those things is a good inspiration for the student and for research at the university. And actually, the student want to use their things to demonstrate how the technology can affect the life on Earth. For example, we are currently building a CubeSat, also funded by Canadian Space Agency. We will put a camera. Students, they want to put a camera, just look down into the north and to monitor the permafrost thawing. So Jason just talking about the cold stuff in north. Now we are talking about in the summertime, what happened if those Arctic ice melted and those permafrost melted? What's the impact to the global weather? It has been already studied, but we want to see how those permafrost thawing will be affected the local infrastructure. For example, the road, the bridge, the house may destroy because they were used to build under the permafrost soil, what never melt, and now it's melted. What happened? So that will provide some early warning or policy making to the local community. And the other stuff like the autonomous things Julie mentioned. Now we are using it for autonomous vehicle, electrical cars, right? They can drive by itself. Those technologies developed from the space. So, and the last thing I want to touch base is the 3D bioprinting. If you want to bring in the tissues, the soft tissue on Earth, it will collapse. You won't be able to do it because of the gravity. And space provide a very nice area. You can printing over there in the zero gravity and make it when grow it and culture it when it mature, send it back. So in the future, there is no surprise. You may be able to print a heart in the space and send it back to Earth to treat the patient.
Wow.
That's just phenomenal.
Yeah, some of these things, again, when I hear them and kind of what we accomplished, it really makes you appreciate how much we can get done when we're passionate and we're driven and we kind of are united in a goal. So it's incredible. I think we're running close to the end here, so I'll leave the last little bit of time for audience questions. If any of you have anything to ask, just feel free to post it in. I'll pick it up. Some of the stuff that I saw earlier was just scrolling up. Cameron asked to Julie, he's surprised only near infrared is used for determining atmospheric composition, and why not other ranges for that purpose?
Thanks for your question, Cameron. Actually, I'm not an expert in transiting exoplanets, but I do know that other telescopes have been used to detect like exoplanets, and it's recent research. We've detected a whole lot more, but for the actual composition of the atmosphere, from my understanding, it's near infrared or mid infrared is what is best for that. But again, it's not my field of expertise, so I'm not quite sure. And there are other spectral ranges utilized, but to my knowledge, it's to detect the exoplanets and not necessarily their atmospheric composition.
Fair. Actually, along those lines, I was curious. I know, well, the telescope is up and kind of in position, but I guess I've heard it's going to take at least a few months or up to 6 months or so to get it, fully calibrated and such. So do you know what that kind of looks like and why it takes so long to get a picture down to the rest of us?
Yes, yeah, actually, that's a very good question. Okay, so and it's pretty much all deployed now. Like everything is unfolded and everything went well. There was a few little things here and there, but nothing major, and everything is as well. But just to give you an idea of the unfolding, the 18 hexagon mirrors that to form like a nice shape, they had to like shift into place, and the movement, the speed at which they move those hexagon mirrors to like get all into this seamless shape. They move at the speed at which grass grows. So it's not like it's like they barely move, right? For like, so it takes a really long time, and we want to be careful, right? Like we want it to be slow because we don't want a jagged movement to break anything. So from my understanding, everything so far has been deployed and unfolded and works. There's communications are online, so we can communicate with it. On Monday, it's going to be inserted into its orbit. So Monday, there's going to be a live event. So if you guys want to tune into NASA and watch that as it's doing orbital burns to get into its Lagrange point to orbit. And the instruments have started cooling down as well, right? From the sun facing side and the space facing side, there's a difference of 300 degrees Celsius. So it's going to be very, very cold, like minus 233 degrees Celsius on the space facing side. And then once it's reached that point, then we can turn on the instruments, the scientific instruments. And we don't want to do it until it's very, very cold because it could damage the instruments. So that's going to take some time for the telescope to cool down, and then turn on the instruments, calibrate everything, make sure the positioning systems are okay, that everything is receiving. So that's going to take a while. So now that it's in its orbit, everything has been deployed. That's what we're going to be doing in the next few months. And obviously, we might start getting some images because we're going to be doing calibration, right? But they're not going to be calibrated. So, it's not really... we're going to test them out, but yeah. So that's it. We're expecting the first images in July.
Yeah, like
Sure.
I'm just dying to see them.
Me too. Me too.
Yeah, I mean, I assume we all are, but I guess we just have to take its time. A question here from Nick Fan for Dr. Zhu. He's curious about the cables that you're detailing in your space elevators. If you have a bit of information to share about that.
The best material is available. It's the Teflon type of tether. It's very strong, very light, actually much stronger than 3 times stronger than the steel we currently have. But it's not fully tested in the space environment because Teflon is kind of polymer-based material. So how long does it last? It need to test.
Understood. I see there was a question for Jason in the chat, but you took the time to reply in the chat already. So
I mean, I don't mind reading it, but so basically the question was, being a CEO, has there been a time where you faced failure and how did you deal with it? And again, everyone that says that failure, they never experienced failure, are really lying to you, because you're constantly going to fail and it's going to be a mental challenge. It's going to be hard. If you're going to space, it's not for the faint of heart, but it is a work of passion and love. If it was for money, I would have quit 8 years ago. But at the end of the day, the best thing to do is use your ambition as a fuel and use it as a determination. There's going to be lots of politics and lots of red tape to cut, and sometimes it's going to be frustrating, and it's going to take a while. But just don't give up. You just got to keep pushing and forging a path ahead and forge your own destiny.
yeah, couldn't say it better. I think we are running very well. We're already far over time, but had to get these last few questions in before we end off the panel. I guess just a quick around the table again, the virtual table. What in the next year, coming years? I know for Julie it's going to be the pictures, so maybe I don't need to ask. But if there's like 1 or 2 things that you can quickly highlight as this is what I'm most excited for, or the most exciting development that's going to come out.
Yeah, I started.
Sure. Let's go counterclockwise for the last time.
Yeah. Okay. So for me, the short term in the last years, I expect to launch our CubeSat, which is a Canada CubeSat project from Canadian Space Agency, and we hope we can take the first image down about North Canada and Arctic, and we want to see the Arctic ice. And we want to see the permanent frost coverage.
Awesome. For myself personally, I like in the short term, I would say I can't wait to perform the first, anyone that's going to be performing it, but the first remote aptics in VR hug from space. So basically have someone in space and someone on Earth wearing aptics in VR and seeing their loved one and giving them a hug from space. And just seeing that human connection is going to be very, very satisfying, because I think it's going to be very important going into deep space. And I guess in the long term is seeing more progress in the industry and having an actual industry in space. And I'm very interested on a personal level to the Venus missions. I know I'm an oddball, so.
Lastly, for
I thought it was skipping me. Sorry. You're right. You were right. You were right. The first images of JWST, that's for sure. There's also a Osiris Rex sample return that I'm super excited about. Seeing, what the asteroid Ben was made of. That's gonna be pretty cool.
that's
and
20,
the loot,
right? I think.
Yeah. And I'm pretty excited for that. And the Lunar Gateway. Not
Artemis.
like Canadarm 3 aside, just a Lunar Gateway in general. It's a while to go, but I can be excited.
Of course. Well, thank you all so much for your time today. we've gone over, so I won't hold us here too much longer. But thank you again so much. Hopefully the audience enjoyed and definitely learned a lot about the kind of technologies that we're pushing and stuff that we will see in the next few years. So yeah, I think with that, I'll pass it to our other SEDS members to close out the day today.
Merci beaucoup, everyone. Watching. Have a wonderful day.
Thank you so much.
Thank you. Thank you for having us. Yeah.
Hello. So my name is Michelle, and I am a staff member on the Ascension 2022 conference team.
Hi, my name is Dana, and I'm also a staff member on the Ascension team.
So thank you to everyone for coming, and a big thank you goes out to all of our speakers today. We have an incredible, oh, sorry, I think I shared the wrong slides.
I can try sharing, Michelle.
It's okay, they're here.
All right,
Okay. Can you see it?
Yeah.
All right, so thank you to everyone for coming, and a big shout out and thank you goes out to all of our speakers today. We have an incredible lineup of exciting speakers and events for the next couple of days of the conference. Tomorrow, we will be hearing from our sponsorship speakers, Sinclair Interplanetary, and our Women in Space panel. We will be learning more about various SEDS projects, and finally, we will end the day with the annual general meeting and social. We heard from the amazing Dr. Farah Alabay today, a French-Canadian aerospace engineer who works at NASA's Jet Propulsion Laboratory, where she is currently a part of the Perseverance rover and the Ingenuity helicopter missions. We also heard from an exciting panel of academic and industry experts who are involved with new technologies, research, and missions. This panel definitely got us excited about all of the innovation and space-related projects coming up for the future.
A friendly reminder that SEDS is recruiting volunteers, what myself and Michelle are, for all these open positions, and we highly encourage you to apply if you are interested at seds.ca/join. Additionally, if you would like to enter the draw to win a microgravity flight with our sponsor, Stardust Technologies, please fill out the form in the chat. And finally, tomorrow's conference activities will start at 10:30 a.m. EST for registration and networking bright and early in the morning. We have an incredible lineup of speakers scheduled for tomorrow, as well as the Women in Space panel. We are really excited to see you there, and we hope that you enjoyed the first day of your conference. Feel free to email conference@seds.ca if you need any help, have equity concerns, or need accommodations. Thank you so much, everyone. Oh. I'll put the link in the chat right now, actually. Oh, okay. Thanks, Michelle.
All right. Thank you all. See you tomorrow.